Hi, this is my first math video. Don't worry, I washed my hands before I made it. Let's start with a circle. Let's draw a circle here, and let's draw a secant line. A secant line crosses a circle twice. In fact, let's draw two secant lines from the same external point, and let's label some points here. What can we say about this rather boring diagram? Well, we can figure out some relationships between the segments if we draw in a couple of extra lines here, AD and BC, creating a couple of triangles. Take a look at triangle PCB and triangle PAD. These overlapping triangles share this angle P. And also take a look at angles D and B. Those are congruent. Do you see why? Yeah, of course you do. You're not dumb. They both open to the same arc, AC, so they're half the measure of that arc. Okay, so because of the angles as marked, we see that triangle APD is similar to triangle CPB. And what can you do with similar triangles? By the way, similar doesn't mean they just look alike. It means they have all congruent angles. Well, we have corresponding ratios are equal. We have PA is to PD as PC is to PB, for example. And if we cross multiply, we find PA times PB equals PC times PD. Fascinating. Alright, remember that equation. Let's look at it again. PA times PB equals PC times PD. Well, let's do something a little more with this. Let's take this secant on the bottom here and rotate it, turn it into a tangent. Tangent touches the circle at just one point. Let's look at that again. As that rotates, A and B are getting closer together until they converge on this tangency point Q. Okay, so PA and PB are each replaced with PQ in the equation, and we get PQ squared equals PC times PD. Pretty cool, but you probably already knew that. Alright, if I rotate the other secant, I can get PR equal to both PC and PD in that limiting process. So PC times PD can be replaced with PR squared, and therefore we get PQ equals PR. Something that's actually quite obvious. The two external tangents are equal. Alright, what can we do with this fascinating newfound knowledge of secants and tangents? Well, here's a problem involving a couple of intersecting circles. The question is to find all points P in the plane such that if you draw the external tangents to these two circles, PQ and PR, you get PQ equals PR. So in other words, for which points P does PQ equal PR? Okay, I'll give you about 10 seconds to think about that. Alright, you probably solved it by now, but I'll go through it anyway. Let's draw this line through the intersection points here of the two circles. If I pick my point P on this line and draw my external tangents, let's label the points like this, I can use my fascinating equation we came up with earlier, the fact that PQ squared is equal to PA times PB if you look at the circle on the left. But if you look at the circle on the right, PR squared is also PA times PB. So PQ squared equals PR squared, and therefore PQ equals PR. Alright, so we found some points. Any point along that red dotted line, as long as it's not between A and B, or at A or at B, will satisfy this equation, PQ equals PR. Well, what if the point's not on the line? Okay, can we still get PQ equal to PR? No, that would be silly, but let's prove it. We can't just say it's silly. If it's off the line, let's draw a line right here through one of the intersection points of the circles, and let's label these points C, D, and E. Since it's off that red dotted line, this blue line is not passing through the other intersection point. Okay, well look at the circle on the left. We know that PQ squared is equal to PC times PD. Okay, but PC times PD is less than PC times PE because PE is obviously longer than PD. And now look at the circle on the right. On the right, we see that PR squared is PC times PE. Therefore, follow the little chain there of equal signs and inequality symbols, and you have PQ squared is less than PR squared, or PQ is less than PR. These are not equal. So if P is off of that red dotted line, PQ and PR will not be equal. Therefore, we've solved the problem, and I'm sure you are much smarter now. Thanks for listening.